Yellow, Mr. Lee here. All right, let's practice your stretches and compressions. All right, so again, this is all part of your transforming functions topic. So we're gonna just focus on stretching and compressing, and even more specifically, I'll have another video, but this first video is gonna be just the vertical component. Okay, so I would say this is like the easier one to understand. Okay, so we're looking at just this section right here. Okay, so we're stretching or compressing vertically, which means you have a multiplier in front of the whole function. Okay, so keep that in mind. You're gonna have a multiplier in front of the whole function. Okay, so let's read what we have here. F of x is equal to x cubed plus x squared, and g is a vertically scaled version of f. Okay, so read it carefully, but g should be the transformation, right? F is your original. They give us the equation, and then g is the vertical scaled version of it. So we're going from f to g, it looks like. Okay, and they're asking us what's the equation of g. All right, so these two reference points are really important. Okay, right now we're assuming we're only doing a vertical stretch, so forget about like translations, reflections for now. You're assuming there's only a vertical stretch. So these are your reference points. You're going from 1, 2 to 1, 5. Okay, but for vertical stretches, if you look at what's happening here, right, in your equation, really your f of x is a y value, right? Your f of x is a y value. If you take that multiplier and you multiply that by the whole y value, that just means that y value gets multiplied by that number, right? So right now I don't really care about the x value, right? They're sharing the same x value. It's 1, 2, 1, 5, but I want to figure out what that multiplier is from the y value of 2 to a y value of 5. Okay, so I'll open up a scientific calculator here just to kind of make some notes. We want to figure out how to get from 2 to 5 as a multiplier. Okay, that's kind of like my question. I'll just write that, 2 to 5. The multiplier, we can use the variable a, right? We're trying to figure out what this a value is. Okay, so we can think of it as like, oh, I'm doing 2 times some number, which we'll call a, that'll equal 5. Okay, so I trust you guys know how to solve one-step equation. 2 times some number equals 5. Some of you can do it in your head, obviously, but divide both sides by 2. Your a value is going to be 5 over 2. Okay, same thing as 2.5 if you want to use that, but we'll use the fraction version because I'm already glancing at the multiple choice on Khan Academy. They do have the 5/2 version right here. Okay, so we'll just stick with 5/2, but it's the same as 2.5. And let's figure out how to write this whole g of x function. Okay, so I'm going to start with f of x. They give it to us right here, right? It's x cubed plus x squared. So I'm just going to copy that over. And very important, right? I'm going to go back to our notes. You have to take the multiplier and multiply it by the entirety of f of x. So that's important, okay? That means I'm going to copy this over. Our new g of x function is going to take all of f of x, okay? Really important you put this parentheses here. You're going to take all of the f of x and then multiply it by that a value we just found, okay? So that in turn will then cause some distribution for the simplification. We're going to simplify it because we don't see any version in Khan Academy that's written like this. This is actually a correct answer, okay? So on a skills check, you could write this as your answer, as long as it doesn't ask you to simplify it, and it would be acceptable. But we have to match Khan Academy's multiple choice, so let's go ahead and simplify it. I'll copy this over once more. The 5/2 gets multiplied to the x cubed, and it gets multiplied to the x squared, right? So your distribution will look like this. It'll be 5/2 x cubed plus a 5/2 x squared. Okay, so that obviously matches option D. So there's our answer. Okay, next. We have a graph of f, and then it looks like function g is defined as 2 times f of x. Okay, so let's do 1 point at a time here. I'm going to go back to my notes. Let's do 1 point at a time. And remember that your x values will stay put, but then your y values on each of these points, they're going to be stretching in some way, right? Or they could be compressing. Okay, so it looks like we have your g function being 2 times f of x, right? So that's 2 is on the outside. And just to kind of be more clear, we can kind of define it, whether it's a stretch or compression. If your a value is bigger than 1, which in this case it is, right? 2 is bigger than 1. That means we're going to look at a stretch, right? It should make intuitive sense because if you're stretching it, you multiply by 2. If you're compressing it, you would see like a fraction in front, like a 1/2 or a 1/3. Okay, so stretching times 2, your a value is 2, which means all of your y values will now get multiplied by 2. X values will stay put. Y values get multiplied by 2. You can even look at this most right-hand column. We don't use this part as often, but it does help in this case, right? All your x values stay the same, and then whatever y value I'm talking about at a certain point, I multiply by 2, or multiply by a, right? A is 2, and then we can shift it over. Okay, so if I just focus on the y value, let's go to this this bottommost point here, right? It has a y value of -2. That means the new y value should be -4. Okay, we can do it all at once. I trust you guys can do this in your head, right? This is a y value of -1. We multiply by 2, we get -2, right? And then this y value is -2. We got -4. This is another -1 times by 2, -2. So if I just go from left to right on these 3 kind of reference points, it should the new y value should be -2, -4, and then a -2. Okay, if I multiplied all those y values by 3. So let's figure out which one has that. -2, -4, -2. -2, -4, -2, right? We can double check that the y values are the same, or sorry, the x values are the same. The reference points were what? -4, -3, -2, -4, -3, -2. Yep, so this was the multiplier. Let's just kind of go through all these options to make sure we're not missing anything, but that should be good. Yeah, this one I think got multiplied by 3. This one got, I think, shrunk by 1/2, so B should be our option, okay? But you should be able to identify it from the y value calculations, right? Take each of these y values, multiply by 2, figure out which one it matches, okay? All right, next. All right, so we have f of x. It's a more complex cubic function. What is the graph of g of x equals 1/4 x cubed plus 1/2 x squared plus 1/4 x? Okay, so let's figure out what the multiplier is, right? So I'll go over here. Let's erase all this. So f of x is x cubed plus a 2x squared plus x, okay? And then g of x is going to be all of this f of x multiplied by some a value, right? Assuming we have a vertical stretch or compression. Okay, so we have to figure out what this a value is. So let's just kind of work backwards. What a value can I put into here to give me a final g of x of 1/4 x cubed plus a 1/2 x squared plus a 1/4? Okay, well, we can just kind of use this first number as a reference, right? Should be relatively simple, but we'll check the other ones, right? X cubed, if I multiply it by a 1/4, then I'll get the 1/4 x cubed. So our a value is probably 1/4, okay? It's probably 1/4. Let's double check everything. If I go back to here, 1/4 times 2, that's like a quarter times 2, you'll get 1/2, right? 2 quarters is $0.50. And then the 1/4 times x that's an easier calculation, plus 1/4 x. Okay, so if I incorporated a 1/4 a value, it gets multiplied to the entirety of the function, which means you have a distribution, so my a value is 1/4. Okay, so that just means now for all these reference points, they should be cut in fourths, right? If you multiply by a fourth, take all your y values, multiply by a fourth, it's the same thing as dividing by 4. Okay, so these should be some nice numbers. Okay, so the y value here is 4, which means your new y value should be 1. Okay, let's go one at a time and just kind of do process of elimination. It definitely can't be a, because that was a stretch by times 2. it could be b, right? Because I have a y value of 1 now. That positive 4 times 1/4 becomes a 1. Are there any other options where it's a 1? Option C, it's a 2, so that's no good. Option D is also a 1, so it could be also option D. Okay, so now we do have to check the other points. It could be option B or D. Okay, we checked this first point. Y value 4 times 1/4 is a 1, so that worked. This one has a y value of 0. Okay, so look, 0 times 1/4, who cares? 0 times anything is 0. So this point should stay, right? This point should stay on the x-axis. It clearly does not on B. It does on D, so D is our winner. Okay, we can check this point if you want, if you wanted, but process of elimination, this is the only one that makes sense. We check 2 points that match perfectly. All right, so 0 times 1/4 there still remains as 0. It's on the x-axis. Okay, let's do one more. I know it's a longer video, but use what you need to, okay? So let's see, function g, vertically scaled version of function f. So again, we're starting at f, and then we're transforming it to a final function of g. Okay, so what is g in terms of f? Let's just figure out from our, our chart here. So f starts here at a 16, okay? I need to try to find the a value. I started at 16 y value, right? I don't care about the x value right here. It's a 4. I mean, but then we go from a 16 to a final y value of 4. Okay, so hopefully you can see you're just dividing by 4, which means it's the same thing as a multiplier of 1/4. Okay, we'll keep it as a fraction because I don't see any decimals here. So that should just mean g of x is equal to 1/4 of fx, right? You're taking all of those y values and just cutting it into 4, or dividing by 4, or multiplying by 1/4, okay? So that's what g of x should be, all right? Found that a value.